Welcome everyone to today's webinar, Transform MongoDB Data for SQL Applications. Chris Doran, Product Marketing Manager, Brad Wright, Senior Principal Product Manager, and Brody Messmer, Senior Software Engineer, will be presenting today's session. I'd like to kick this off to you, Chris, and hand you the ball.
Thanks, Marlis. Thanks, everyone, for joining us today. So as Marlis said, my name is Chris Doran. I'm the Product Marketing Manager here at DataDirect for our on-premise products. To start things off today, really what I want to talk about to set the stage is how do organizations leverage SQL access today? Really, 6 main areas that I want to talk about. BI analytics applications, which you notice up in the left-hand corner, which require consistent SQL access to a wide variety of different data sources. Next, we have the new web applications that seem to be emerging every day, for example, building the web portal. As you go through all of these examples, it really dovetails in what we're going to talk about today, and that's MongoDB and SQL access to that critical data. To take this a little bit further, when you think about how to access that data, we think about 6 data access challenges, whether it's large volumes, high performance, that's standardized SQL access, high transactional, and then obviously there's a major security and bulk protocol opportunity. So what that brings us to is who we are. For those of you not familiar, at Progress DataDirect, we focus on data connectivity for a wide variety of data sources. We grew up in the relational world. We have some folks here who helped develop the ODBC protocol, so data connectivity and data access, I should say standard-based data connectivity and access is who we are at our core. This is just a sample of all the sources that we connect to via this sample standards access. But really, you'll notice Mongo on the corner, and we'll really get into why this was a big focus. So that brings us to the topic today, and really it's simplifying the chaos of the data variety explosion. For those of you who may have attended the MongoDB World Conference a couple weeks ago, Brad, Brody, and I were there. And during my recap of the show, I really talked about sort of something Mike Olson hit in his keynote address. And for those of you who don't know who Mike Olson is, he's the Cloudera CEO. He talked about a data universe of the future. And that's really how we see it and how we approach this. We really feel that Mongo is a core piece of that data universe where you have many different systems and technologies that really need to collaborate together. And so how do you simplify the chaos that brings that sort of variety in that new data universe? So when we think about MongoDB and simplifying that chaos, we first took a lot of time because we wanted to build the most robust and best of breed data connectivity solution for MongoDB. And we really looked at the industry, what was out there, what people were doing, because we knew that standards-based connectivity was continuing to be a growing challenge. And we heard from our partners and current customers that the industry approach now just wasn't really solving it for them. So when you think about it, really what you see for solutions on the market is to flatten that data. When I think of flattening, I think of essentially squishing the data into a big fat rectangle. So this really isn't straightforward. For those of you who have applications who want to consume it, you know it's not natural for your applications to do that. And if you can see the example below, you see the JSON document and how it's essentially flattened into one row, and you have multiple instances of email addresses. We knew that this wasn't the best approach, and we worked hard to sort of research and find a solution for it. So this month, pushed out our new data connectivity approach to MongoDB. We like to refer to it as normalization. So we talk about normalize, and we throw it around because to us it's a patent pending concept where you can actually take non-relational data in Mongo and make it look like a relational data source. It, in our view, provides the most natural and flexible representation of the Mongo data, which, as you know, is in the document style is not set up in the way that applications expect to consume it. If you look below, it's sort of an example, and we'll kind of talk more about it, but you see that same JSON document where you have a name, Brody, we used as an example. You have an address and multiple emails, but rather than place it in one row, we now have separate tables, one for employee address, and then the instance of multiple emails has two rows in the table. So really, when we think about normalization, there are some key benefits that we like to talk about. It's really exposing the complex types that are familiar to those who are used to SQL. I know in my conversations at Mongo World, several folks told me about their teams that were used to working in SQL and didn't know how to work with Mongo, how they had to go hire new developers to work on Mongo because they didn't have the skill set. And what we feel is we provide a solution there. We also provide flexibility, so you can take advantage of what Mongo offers. So as your arrays grow, your table definitions can remain constant. But we also provide the flexibility as well to change that. So we provide the best of both worlds. And then really the other thing that I want to talk about is the concept of joins. I know my conversations that I've had with people about this solution, that's really something where you can take advantage and really of Mongo data and capture it in a way where flattening you can't. And so you can do that join, that complex join that you're used to with your SQL data. So really, when I look at it and I look at a flattened sample of Mongo data and a normalized sample, I really think it's a beautiful piece rather than a flat rectangle. Seeing the data exposed as a table makes it, to me, look like a much more attractive way to work with my data. So just to talk a little bit more about the Mongo solution that we offer, I'm actually going to turn it over to Brad, who's going to talk to some of the technical components of the driver architecture.
Hey, thanks, Chris, and welcome, everybody. My name's Brad Wright, and I'm the Senior Principal Product Manager, as Marlis introduced me. And I guess maybe to sort of pick up on Chris's theme about recapping our experience at the recent MongoDB World Conference, which was incredibly well attended, I'd like to maybe sort of, as we transition into a little bit more of a technical conversation about our new MongoDB standards-based connectivity, maybe clarify the pain that we heard quite clearly at the conference, and that is organizations are rapidly adopting, large organizations are rapidly adopting MongoDB because MongoDB has a very strong appeal and strong set of differentiators and a strong value to developers and to those folks responsible for constructing operational systems based on the MongoDB principles of schema agility and schema flexibility and sharding and scale. And all of those strong appeals to developers constructing systems. But once those organizations have built those operational systems and put them into production, that's when the needs of the rest of the organization start to emerge and maybe are unfortunately a bit considered after the fact, and that is, how do you integrate that data that's now stored in MongoDB and captured as JSON documents? How do you integrate that data into the rest of the corporate data ecosystem, whether it be data warehousing or data management or ETL products or ultimately BI and analytics? There's some individual that sits somewhere in the organization, a decision maker, that needs to consume data that now is in MongoDB. How do you get that data out to that individual? And that's where these values of normalization and being able to better express the fidelity and the complexity of JSON data in relational semantics really becomes a key win. And that's in all of our conversations at MongoDB World, led us to reconfirm that conclusion. With that sort of pain recapped, let me then describe to you a little bit more about our offering. We released, as Chris indicated earlier, several weeks ago, late last month, I should say now, our new MongoDB standards-based connectivity products. They take the form of ODBC and JDBC drivers. Obviously, our DNA as an organization has been in providing that standards-based connectivity. The point of this slide here is to give you a little bit of a technical detail, a little bit more technical detail into what form those drivers take. They express themselves as ODBC and JDBC, but you can think of them, and this is sort of the phraseology, if you will, that I ended up using at the conference, because frankly, people asked a lot of questions about this. How can you, in fact, do this normalization in an ODBC and JDBC driver? And so I took to describing them as sort of, for lack of a better word, a fat ODBC and JDBC driver, in the sense that our ODBC and JDBC drivers contain in them an in-memory query engine, a lightweight query engine that's used to accept that incoming stream of SQL and build a plan, if you will, for how to map that SQL into queries to MongoDB in the form of BSON. So they are ODBC and they are JDBC, but there's also something more in there. There's some stronger intelligence in there than maybe what would typically be in a pure relational ODBC or JDBC solution, and that is this lightweight query engine that ultimately is about taking that SQL and figuring out how best to optimize that retrieval request in the context of this normalized view, this relational view, on top of potentially complex JSON documents, and really make that happen in the form of submitting BSON-based queries directly to the MongoDB cluster socket. So think of it, to the extent that it's helpful, that there's some enhanced intelligence in our ODBC and JDBC solutions. So, what this ultimately is all about is providing more powerful ways of representing complex JSON document structures, nested JSON document structures, or arrays in JSON documents in relational form or in relational semantics that are meaningful to relational consumers. And Chris gave a couple initial examples of that, but let's spend a few minutes going into a little bit more flavor of this. And one of the key concepts that's in JSON, that's part of JSON, is this notion of an array, multi-valued field in the context of a JSON document. And, picking up on Chris's earlier comment, there certainly are ODBC and JDBC standards-based solutions that are already on the market that provide MongoDB connectivity, but they all take the form of flattening. It's called flattening. Turning that complex JSON document structure into one big flat rectangle. And if you think about arrays in particular in that flattening paradigm, you can pretty quickly come to the conclusion that that's not an optimal approach, not ideal, and frankly problematic from the perspective of that decision maker that's sitting at the end of some large SQL-based data management infrastructure either in the form of, again, ETL or directly connecting BI and analytics tools to Mongo, in the sense that, from the perspective that an array that has 3 elements in it in one document in a MongoDB collection would be represented as 3 columns in that rectangle, that flattened rectangle, but another document that has 4 or 5 elements in it, because that's the whole point of an array in a JSON document, what's that going to look like in that flattened context? Is it going to be 3? Are you going to lose some of that data in the context of this flattened relational schema? Or is that relational schema, that flattened schema, going to arbitrarily vary document to document in the collection? Ultimately, that's the other great phrase that we heard at the conference was this notion of unnatural JSON acts. This sort of gets to the crux of this unnatural act, that flattening these complex structures in JSON is ultimately an unnatural act. The opposite of that, taking JSON and simplifying it into a flat rectangle, is sort of an unnatural act in order to fit that data into the relational ecosystem. So the end of the key point here is that you need more than flattening, and you need this intelligent JDBC and ODBC solution that can do normalization and take arrays and turn them into these normalized tables. So if we look at that first example, the outer root level portion of that JSON document, the name, in a normalized model and mapped into this relational semantic, this normalized relational semantic, is a separate root table, employee. But that array portion of the JSON document is much more naturally, from a relational perspective, mapped into a separate table, in this case employee addresses, where the array elements in JSON become rows in the context of the relational mapping. That way, relational consumers see the data in a fashion that's stable and optimized to their needs. Document to document, if there's 3 elements in one document, and in the nested array of one document, and 5 in another, and 20 in another, those become rows. That is the way to map an array into relational semantics. So that is something that our solution absolutely does. And likewise, sort of documents within documents, embedded documents, those two, maybe in some cases it's appropriate and acceptable to flatten those. And we're not saying that flattening isn't sometimes a reasonable option. I think what we're saying is that it is insufficient. So some cases flattening is fine, but in reality, a more appropriate way to represent nested document structures and nested documents in JSON to relational consumers is, again, as a normalized table, a separate table, so that, again, the root level of the document in a normalized approach, in our normalized approach, becomes the employee table in the context of this example, which is about employees, and that employee address becomes a separate mapping table, a virtualized table. So hopefully this is beginning to give you some sense of the real power in our solution in terms of going above and beyond flattening and the normalization patterns that we can supply. So there's lots of permutations and lots of combinations here of nesting and arrays and how deep they can go into JSON in the context of a MongoDB collection. What you'll see again is arrays represented as normalized virtual tables where the data in them become rows, whether they be single value or simple type arrays that contain only simple types, or whether they are arrays that contain themselves embedded documents. This is the case of arrays of embedded documents. Here you see those embedded documents in that array now represented as rows in that employee address table. And it can go on and on, embedded documents nested within an embedded document. Again, here there's the power of mapping that into, a separate relational table that makes more sense for the relational consumer. And arrays nested within embedded documents, same sort of thing. And on and on and on. So the point here is flattening is appropriate in some situations, but flattening leads to unnatural acts, either in terms of how you're representing that data to relational consumers and making that decision maker's job harder at the end of that ETL and data warehousing infrastructure, or you're mitigating and minimizing the value that you can extract and receive from adopting MongoDB as a data source in your operational systems by sort of dumbing down, if you will, the JSON that you allow in those collections. Again, this unnatural act in order to fit into the relational schema. We believe what's required to eliminate those unnatural acts is this normalization capability, and we heard that over and over and over again at MongoDB World. Now, there are some limits to our current offering, our initial offering. Again, we just released last month. I sort of talked about how there's sort of arbitrary levels of permutations of arrays and nesting that can occur in JSON. We can, our solution currently can go down so far, but we are planning a release shortly and adding capability that we will be able to go even deeper into the JSON document with this nesting, with this normalization. So I think with that quick introduction, well, maybe not so quick, talk about the technical flavor. Chris, did you want to take back over, or did you want me to just continue on?
You go ahead and continue on.
All right, perfect. So, here's maybe the question that's in everyone's mind now. Brad, great, I get it. We don't like unnatural acts. We don't want our decision maker at the end of that BI ecosystem to see data that isn't optimized to their needs for decision making and relational. But yet we also want to maximize the ability or the value that we get from MongoDB by, exploiting the fidelity and power of JSON. And we get that normalization, gives us that capability to sort of bridge these two worlds in the context of business intelligence and analytics. But how does that mapping occur? Who makes those decisions? And that's what this slide is really about. Along with our ODBC and JDBC drivers, these drivers that have this intelligent, lightweight query engine in them, we provide a tool to you, a small user interface that's called the Schema tool. And it's through that tool that you use, or some domain expert or DBA or individual who has the knowledge about the types of JSON documents and the data and their structure that exists in the particular collections that you need access to in MongoDB. They use this tool one time out of band to make those mapping decisions about what pieces of the document, the JSON document, get mapped into which of these normalized views and normalized tables. And that information gets saved off and consumed by the query engine that's in our ODBC and JDBC drivers to make this normalization, to apply this normalization on the fly at runtime. We're not copying the data. We're not extracting the data. We're not storing the data anywhere. This mapping happens as you consume, as you query MongoDB. And it's with this schema tool that you perfect that normalized view. And using the schema tool, so the other challenge here, or another challenge here, is that MongoDB does not provide any metadata about the documents in a collection. So in order to make those decisions about perfecting the mapping into this normalized view, the schema tool also does sampling. It samples the most recently touched documents in a MongoDB collection presents that information to this domain expert and the statistics about that information and some proposed type, recommended types about the elements that are in those JSON documents as part of this schema perfection, so that that individual can identify the types that are most appropriate in the sizes, identify and create, appropriate column and table names for that ultimate end consumer, hide things that they don't want to hide, that they don't want to expose. You don't have to expose everything through this process, and even in some situations add columns from different pieces of the document. So that's really the other piece to this equation: normalization, lightweight, intelligent query engine in our ODBC and JSP driver, and then this standalone schema tool for perfecting that and making the choices about how that mapping occurs. And at the end of the day, what this is really about is creating a contract between the rest of the relational ecosystem and how they are going to consume and view and query MongoDB data stored as JSON documents in collections. The ultimate goal, of course, is to ensure that that schema is stable, number one, and changes only in controlled ways that don't break the SQL application, the ultimate consumers. So this really is, this schema, this normalized schema really is a type of contract, a read-only contract. And, to the extent that it's helpful, not everybody's going to be able to see the sort of specific writing or fields that are on these screenshots, but here's just a sort of quick look at that schema tool. On the left, you've got the DSN. This is part of every ODBC-based solution, providing connection details to the ODBC driver in order to know how to connect to an instance of MongoDB. Then in the middle, you see the specifics about that connection and whether you want to reuse an existing schema definition and create a new schema definition. And ultimately, the most important piece on this particular slide is the right-hand screenshot. That's just a quick look at the schema tool. It's quite simple, quite straightforward. Really, one screen gives you that hierarchy of metadata that's been introspected from the MongoDB collection, the database and collection, and then presents the statistics for the various items as you click through them, and then gives you choices about how to order that in a normalized view and what the editable column names are going to be and which ones you want to delete and what types they should be, etc. Very simple and straightforward to use. Up and running in minutes. But maybe the next nuance that some of you might be scratching your heads about now is, great, normalized, great, there's a tool for me or an appropriate individual to perfect that schema, to create that contract, to give that stability ultimately to the end relational consumer. But MongoDB does not require every document in a collection to be the same. Documents can vary instance to instance. The contents of those documents and whether there's an array or a nested document in them can vary instance to instance in the collection. So what happens in that situation? So that's what this slide is about, our policy and approach for dealing with dynamic and or AKA inconsistent schemas. And really this is about, if in that contract, in that mapping, there is a field that's mapped or a portion of a document that is mapped, whether it be an array or a nested document or an element in a nested document, if that item is missing in a particular document that's being processed as part of a result set, we'll substitute null. If types vary, if the field contents vary, integer in one document instance, string in another, and maybe the schema perfection was such that you mapped that to string. The driver, our solution, our query, this intelligent, lightweight query engine is going to consume that metadata and attempt to apply effectively some coercion rules to that typecasting problem. So we're going to do this in a smart way, and we're going to preserve that contract. And if pieces of that contract cannot be satisfied by the contents of a particular document instance that's being processed, we'll substitute in the appropriate nulls. And so we've talked about this problem really from the perspective of read-only consumption of MongoDB data, and that is in fact the primary pain that exists in the market. In terms of connecting the BI and analytics or data warehousing ecosystem to MongoDB data in a high fidelity way. And to be clear, we are not targeting our solution, ODBC and JDBC SQL-based solutions, at the problem of MongoDB application development. MongoDB app dev, takes advantage of some native APIs that are part of MongoDB, and those native APIs expose the full fidelity of MongoDB collections, and that's ultimately why developers want to choose or do choose MongoDB, so that they have access to that full fidelity. So we are not targeting the app dev portion of the problem space here of the market. That's handled by MongoDB and their native capabilities. We're targeting that, that connecting and the BI and analytics-based ecosystem to that data. But having said that, we know, based on our experience with our customers and their requirements that they communicated to us as we embarked on this product development effort, that there are some limited cases where that BI, that SQL-based ecosystem may want to write back into Mongo. And so by default, our solution is configured to be read-only, but it can be enabled via an option to support limited insert, update, and deletes into the root level of a collection, of a document in a collection. And so I just want to make sure you're aware that there is some limited write capability into the root level of the document, but that is something that you have to turn on. And there are a number of things that our solution does in consuming this metadata captured by the schema tool and in optimizing the SQL query that's received, whether it contains joins or doesn't contain joins, whether it contains aggregation or doesn't, into a stream of BSON queries to MongoDB. And in general, there are important things that our solution does in that we support intra-collection joins. That is, if the SQL that we receive is a join between two table constructs that are ultimately mapped into the same collection, that is, different portions of a JSON document in a collection, we know that we can turn that into a single round-trip query to MongoDB, not two queries to MongoDB. So we can optimize that into one retrieval. So it's lightning fast. And where there are predicates on the where clause of the incoming SQL, we can pass that down as find queries to MongoDB to ensure that MongoDB is exploiting all of the great power and expressivity and performance that it provides. Now, having said that, there are some things that we cannot push down to MongoDB because MongoDB either doesn't do them or because the SQL semantics of those operations are subtly or different or potentially different than the equivalent or nearest equivalent MongoDB semantics. So things like inter-collection joins, MongoDB just doesn't do that. Yet relational consumers are going to want to be able to do that because they're not going to know which of these tables are mapped into what documents, whether they're in a collection or in one collection or in another collection. So that's something that we'll do in this lightweight query engine. Things like sorting and limit and to current capabilities and the current extent, grouping are things that we do in our solution because the semantics of sorting, the SQL-based semantics of sorting do not currently map directly into the equivalent MongoDB semantics. So sorting, scalar functions, group by, limits, those are things that we need to do in the driver. And just sort of maybe wrapping up the technical portion of our webinar today, I think we're getting close. I think this might be the last slide. You know, we've talked about read-only, and we've talked about being able to turn on limited read-write capability from that BI portion of the ecosystem. Again, not targeting the primary app dev portion or the app dev problems with our solution. But in those cases where that BI ecosystem does need some limited ability to write into the root level of a document and a collection, different relational consumers have different expectations and behaviors in terms of their expectations around transaction support. And we've learned through years and years and years of experience in providing solutions to products that are not strictly relational, that we need to provide these sort of two transaction modes. One mode where we say, nope, there are no transactions, and the application is fine with that. And the other mode is where we sort of fake it and say, yeah, there are transactions, and we're going to effectively lie to you about their state, because the underlying source doesn't really have the same level of transaction fidelity that a relational database would have. And that's that second mode where we do ignore. And again, this is really about the needs of the ultimate relational consumer. Most everyone in just the primary problem space of connecting from read-only into the analytics ecosystem, won't have to deal with any of this transaction mode capability. So with that was the last of certainly our technical content, but it looks like that was the last of our prepared content for our webinar today. So I believe I'm going to pass it back to Chris and Marlis. We as the group are going to take some Q&A. So the first question here is, can this be configured to represent all one-to-one relations as one table? And I guess I'm not quite sure what the question is getting at.
Hi, this is David Brzezlonkin from Citi. In other words, I get that you've got the mapping and you can configure the mapping in the mapping tool. Is there a way to create global mappings? I mean, it's not so important given that you've got the mapping tool. But in other words, to say, look, if I've got a bunch of documents and there's just one-to-one across all of them, that's automatically, a column in the table. In other words, you had, for instance, you had the employee table, then you had the address table, then you had the email table. Well, now, if the employee can only have one address, that's a one-to-one.
Right.
So why not just move that into the employee table?
As I understand that, that's actually going to be the default policy that's applied to how this metadata is mapped. So maybe Brody can clarify a little bit there.
Yeah, so I mean, simply said, the schema tool gives you complete flexibility of how you want your schema exposed to the ODBC or JDBC application. So if you want those embedded documents, which are the one-to-one relationships you're talking about, if you want those essentially flattened in kind of that parent table, you can absolutely do that. If you prefer to have them normalized, you can do that as well. Like Brad said, if you take the driver and simply connect to MongoDB without running the schema tool, you'll actually get a flattened schema by default. And if you run the schema tool, when you first run it, you'll be given the option whether you want to normalize everything, flatten everything, or you can start with really an empty canvas and import tables one at a time and get complete control over exactly what portions are normalized and what portions are flattened.
Right, so the next question is seems to me that if a mapping to a complex type exists, then you ought to be able to support writes to complex objects by embedding the writes within a transaction. So I'm actually going to ask Brody to speak to that.
Yeah, so I mean, we love tackling challenging problems. And adding full write support is something that we are certainly capable of doing. For our initial go-to-market, we were very much focused on kind of BI reporting, analytics use cases. So the write functionality that we implemented was really just enough for us to accelerate some things internally and allow others to get basic write capabilities. It certainly isn't a far cry from being able to do full writes to complex types, but our initial go-to-market did not include that functionality.
So maybe just from a PM perspective, putting the PM flavor in there, we absolutely, so picking up what Brody said, we could go on and on and on and provide additional capability, whether it be separate transactions or whatever relational form it may take around rights. But our focus is right now based on the pain that exists in the market, which is overwhelmingly about read and connecting MongoDB data in all of their complexity, or in as much complexity as is reasonable, that good old PM 80/20 rule, into the relational ecosystem. And so our focus right now is on read, and our focus is on taking our unique, different, our what we believe is highly unique capability around normalization behavior and applying those patterns further and further and further along those various JSON permutations. So that's not to say that we won't get to the point where write becomes a significant problem in the market, but we just frankly are not seeing that as the primary pain currently, so that is not where we're focusing. So there's a question about time frame for complex writes, and I think with that, with what I just said, I can't really provide a time frame because currently we do not see that pain in the market as in a significant way. Markets, of course, change, and roadmaps and plans change along with them. So right now, we do not have any plans for providing providing write in insert, update, and delete into deeper portions, non-root portions of the document. We do not have that on our roadmap. So another question came in, and that is, how is performance compared to native MongoDB read queries? And I know Brody, we just got asked this yesterday. I was on a call with Brody with a prospect, so I'll ask Brody to speak to that.
Sounds good. Great question. So the driver performance is going to vary a little bit. If the driver's doing a fairly simple select where it's able to avoid any sort of heavy lifting within the driver itself, so the driver's not having to sort any results, it's not having to do any group bys, the performance is pretty much going to be the exact same performance that you see from a native MongoDB client. In the case where the driver is having to do some heavy lifting, it's really going to depend on the amount of data that you're dealing with. And currently we don't have any, specific lines of measurement there to say, okay, well, if you're operating on this much data, it's going to perform in this sort of way. That is something that we're working on. But the simple answer is, if you're doing an operation that can be fully passed down to MongoDB, you're going to get the exact same performance that you see from the native MongoDB client. There's no overhead associated with kind of the advanced mapping that we make available.
Thanks, Brody. So any other questions? That's the questions that we've received so far.
No, I think those are all the questions we've received. And of course, if anyone has any further, they can always reach out to the team. And today's session was recorded. There will be an email sent out to everyone who has registered. And stay tuned for that. And does anyone have any closing comments, or should we just give everyone an extra couple minutes to get to their next meeting?
I will just thank everybody for participating and thank Chris and Brody for joining and hosting, and wish everybody a great day.
All right, well, thanks.
And of course, thank Arliss.
All right, thanks, everyone. You can log off. Appreciate you joining us.